Hi, hi, welcome to my YouTube channel. And today we describe the very important to find the inverse. And previous video we discussed the minor and cofactor of determinant and adjoint and inverse. Find the adjoint and find the inverse. But here today we discuss the very important question for 12th related to inverse matrix. How to find the inverse matrix, and given that a square matrix where row and column are same. And we discuss the uh, inverse matrix, how to find. Before starting you guys to subscribe to my channel. And second thing, sure that you watch this video completely and share it with friends and like it button. Here look carefully. I want to say something word. Good pen, good teacher, good book can change life. And today is Makar Sankranti, so I guide it lie, sugar cane and other sweets, and cut with sugar and chew. And look here carefully on the board. Find the inverse of matrix 1 2 3 4, where this matrix is a square matrix and order 2 by 2 order 2 by 2, because number of row and number of column are same. Then which matrix called square matrix. And find the inverse of this square matrix. Let A is equal to any square matrix and find the inverse. Before find the determinant, we know that A inverse is equal to adjoint of A by determinant of A. Here be carefully, A inverse is equal to adjoint of A over determinant of A. Then before find the minor and cofactor. So we know that minor passes through the element Aij. Then minor is denoted by Mij and cofactor is denoted by Aij. So then cofactor is equal to -1 I sum of Ij into Mij. So then we reached here A11 cofactor, where A11 cofactor of first element. Cofactor of 1 is equal to first row, first column, yeah, ith row and jth column are deleting. Then left element 4, then multiply by 4, because where 4 is minor. 4 is minor, then we know that um, uh, minor is multiplied by sum of row and column of -1 and of mij, where I is equal to row and j is equal to column. Then we can see that here 4 is cofactor a11, 4 is cofactor is 1 and and what 2 is equal to second cofactor of 2, cofactor of 2, the here second column or second row deleting the then left element 1 and 1 is minor and 1 is multiplied by sum of row and column of power of -1 is equal to -3, -3. Here second element a12, where a12 is called 2, then second column and first row deleting the left element 3, the 3 multiply is equal to -2, because 1 plus 2 is equal to 3 and power of -1, 3 is equal to we get the -1, because here -1 multiple -1 multiple -1 is equal to minus plus and plus minus is equal to minus. Here we get minus, there sign of negative, and a21 is equal to cofactor of 3, a21 is equal to cofactor of 3 is equal to 3. Here second row first column deleting we get left the element 2 and multiply by 2, then -2, because power of 3, so we get the negative sign, the -2, and other term is here a22 element of a22 cofactor of 4 is equal to -1 and power 2 plus 2 multiply by 1 is equal to 1, and we get the new matrix B, and we change the transpose and we find the transpose of B, then row change column and column change row. Then B transpose becomes equal to adjoint of A. Here we can see 4 minus 2 minus 3, because first row change in first column and second row change in second column, and we know that A inverse is equal to adjoint of A by determinant of A is equal to substitute the value of A adjoint of A and determinant of the value of determinant is 2. We find the determinant 2, we get the determinant -2 equal to -2 divided by every element in the rectangular figure. The -2, the 4 by -2, the 2 to the 4 and sign minus, and second element -2 by -2 cut off -1 and -3 -2 minus cancel, and 3/2 and 1/2 and minus sign, and second order matrix find the inverse of A, and I hope the student have understood this method. We can the inverse of A, and how to find the inverse of 3 by 3 order and square matrix. Look here, find the inverse of the matrix 3 by 3 order, and how to find the inverse of A inverse and 3 by 3 order matrix, and listening carefully here. uh, Find the inverse of the matrix. Find the inverse of the matrix, and we consider the matrix 3 by 3 order, and row and column are same. Then then to find the inverse of A, let A is equal to this matrix, and determinant of this matrix we get -2 does not 0. Then this matrix is non-singular matrix. We can find the before this matrix is non-singular, yes, singular matrix. Then determinant we get the -2 does not 0. Then cofactor of A11, cofactor of A11 is equal to cofactor of 0. The 0 element cofactor where A11 is a cofactor is denoted by Aij and minor is denoted by Mij. Then cofactor of 0 0, then cofactor the first row and first column deleting, then left element we write here 2 2 3 1 1 2 3 1 1 is equal to 2 minus 3 is equal to -1, and A12 is equal to cofactor of 1 1 is equal to minus power of 1 plus 3, or we get the power odd number, then negative sign. Then we get the negative sign, and A12 the second element, and second column deleting, then left element 0 2 3 1, and we write here 1 2 3 1, and we get the -1, so on. A13, A21, A22, A23, so on, each by element finding the cofactor. Then and A1 3 is equal to cofactor of 2, then second column and first row deleting the 1 2 3 1, the 1 2 3 1, and cofactor -5, and A21 A21 the cofactor of 1 is equal to A21, the A21 then 1 2, then 1 2 1 1, then 1 2 1 1 is equal to cofactor, and A22 second row and second column deleting, then 0 2 3 1, the 0 2 3 1, and A23 cofactor of 3 so second column and third column and second row deleting deleting the 0 1 3 1 left, the 0 1 3 1 is equal to 3. And next, last and second third row, finding the cofactor. Here a31 cofactor of 3 second row and first column deleting. Second third row and first column deleting the left element 1 2 3 2. Then we write 1 2 3 2 3 is equal to 3 minus 4, 4 is equal to minus 1, and multiply by 1 3 and 2 2 is 4. Cross multiplication, तो 3 1 जा 3 and 2 4 2 2 जा 4, 3 minus 4 because minus 4 4 is greater than 3, so then put the minus 1 is equal to minus 1, because minus 1 sign is minus 1, and a32 is equal to cofactor of 1, the 1 third row deleting and second column deleting, the 0 2 1 3 left element, the 0 2 1 3 and cofactor 2. a33 last element, the third row third column deleting, the 0 1 left element 0 1 1 2 0 1 1 2 is equal to 0 minus 1 is equal to minus 1, and a new matrix B. Here new matrix we get the B is equal to a11 a12, where a11 is cofactor of a11 and a2 is cofactor of a12. So we write a11 value, substitute the value of a11 minus 1 minus 1 8 minus 5 1 minus 6 3 minus 1 2 minus 1, and adjoint of, we know that adjoint of A is equal to transpose of V matrix, and let V matrix is equal this one, and transpose of B is equal to change of first row change of second first column and second row change in second column, then can see here, and we know that A inverse is equal to adjoint of A by determinant of A is equal to adjoint of A by minus 2 is equal to, and adjoint of transpose of V matrix, and substitute the value of adjoint of A, the adjoint, and divided by minus 2, so, 1 half minus half minus 4 3 minus 1 5 by 5 over 2 minus 3 over 2 1 over 2. And I hope the student have to understand this method and find the inverse, and I hope enjoyed it, and this video I shall see you again, come soon. You practice this method every day, then remember that this matrix and formula and theory, remember every time, everywhere. We can use useful formula. Thank you so much. Thank you very so much and watching this video. Thank you so much.